If AB is a semicircle, then what's the area of this composite shape? Well, we've got a semicircle and a right triangle attached to each other, and we're asked to find the total area. And in order to do that, we need to find the length of AB. Now, since the blue triangle is a right triangle, then we can use Pythagorean theorem, a squared plus b squared equals c squared. And substituting in the values I know for the legs, we get 3 squared plus 4 squared equals c squared, 9 plus 16 is c squared, and finally 25 is c squared. To get that length, we need to square root both sides, and that means that c is equal to 5. And so I'm going to substitute in that as my known value. Now, not only is this the hypotenuse of the triangle, but it's also the diameter of the semicircle. So next, I'm going to find the area of the circle. The formula for this is area is equal to pi r squared. Now the diameter is 5, which means the radius is half of 5, or 2.5. So I'm going to substitute that in. Area is equal to pi times 2.5 squared. 2.5 squared is 6.25, giving me this next line. Now that's the area for the entire circle, but since this is a semicircle, I'm going to divide that by 2, and that gives me 3.125 pi. So now that I know this value, I'm going to put it here, and I'm going to solve for the area of the triangle. Well, a triangle is easy. Its area is equal to half base times height, and if I sub in my base and my height like so, I get an area of 6 units squared. So now that I have both of these areas, all I need to do to get the total area of this is to add up the two values I have. So total area is equal to the area of the triangle plus the area of the semicircle. Now if I want an exact answer, I need to leave pi in it. So it's going to be area is equal to 6 plus 3.125 pi square units. But if I want to round it, then this will be approximately 15.817 squared units.